Hi everyone, today we're going to look at some conservation of energy problems. I'm going to do the first problem with you and then you'll do the remainder for your assignment. The assignment will not be due until the second class, okay, at 9 p.m. So let's look at, we have our formulas. We have our kinetic energy formula, 1/2 mv squared. We have our work equals force times distance. We have work is a change in kinetic energy or a change in potential energy, depending on the situation that's where it's involved. And then I changed this is, they have gravitational potential energy equals mass times the acceleration due to gravity times height. I just changed it to our familiar PE equals mgh. So you can change that one. All right, so let's look at our first problem. We have our roller coaster. The chain on a roller coaster applies a force of 1,000 newtons. So we have our force. Okay. It's pushing a 250 kilogram roller coaster. So kilograms means it's our mass. Up a hill that is 100 meters long. So that's our distance. Okay. So they want to know how much work did the chain do to pull the car to the top of the ride. So we need work. We need to find work. So let's use our work equals force times distance. So our force is 1,000 newtons. Our distance is 100 meters. And that'll give us 100,000 joules. So it took 100,000 joules of work to get the cart to the top of the hill. Now we know joules is also the unit for energy. So that means at the top of the hill, it now has 100,000 joules of energy. We're going to say when it's up there, it's not moving. So that's going to all be potential energy. So they want to find the gravitational potential energy at the top of the first hill. Well, we know that work equals our change in potential energy. It was 0 at the bottom of this hill. Here's right here at the bottom, it was 0. Okay, we did work, or the car did work, the chain did work, and now it has 100,000 joules of potential energy. Okay, so if you look down at the bottom of this sheet, this one, they're going to ask you to find potential energy based on the height, and it gives you mass also, I believe. If we look at this, hold on. Right, they give you mass so you can find potential. Then they're going to ask for part 2, for B, how much work was done. It's the same thing we just did, but now we know potential energy. We can just say that was the amount of work. In this problem, we started with work and we can say, well, that's how much potential energy it was. Okay, now they want to know what is the kinetic energy at the bottom of the first hill. So here is the bottom of the first hill. It is the same as the bottom of where the cart started. So we know at that point, okay, there was 0 joules of potential energy. Okay, so if we think about that, that means all the energy, the 100,000 joules, was converted to kinetic energy. Okay, so there's 100,000 joules of kinetic energy right at the bottom of this first hill. And now they want to know how fast the roller coaster is going at the bottom of the first hill. So we know the kinetic energy, which we just said was 100,000, is equal to 1/2 mv squared. So that means we can say, okay, 100,000 joules equals 1/2 the mass, which we said was 250 kilograms, times v squared. Oops. Okay. So we need to 1/2 of 250, 125, divide our 100,000 by 125, and then we need to take our square root because we have v squared. So we end up with a velocity of 28.3 meters per second. Okay. So again, we divided 100,000 by our 125, and then we took the square root of that to find our velocity. Let's go down. Oops. Hold on, sorry. Okay, if the next hill has a height of 25 meters, determine the following: the potential energy, the kinetic energy, and the speed. So let's figure out potential energy. We have a height of 25 meters. Underline that, 25 meters, that's our height. We know potential energy is mass times, equals mass times gravity times height. So we have 250 kilograms times gravity, which is 10, times our height, 25 meters. That gives us a potential energy of 62,500 joules. Well, we know we started with 100,000 joules of potential energy. That's our total mechanical energy everywhere. So let's say kinetic energy equals the total minus the potential at this point. So 100,000 minus 62,500, and that equals 37,500 joules. So that's our kinetic energy. And now that we know our kinetic energy, we can get our speed or our velocity using our KE. KE equals 1/2 mv squared. So 37,500 equals 1/2 250 kilograms times v squared. We divide 37,500 by 125, and then we take our square root, and our velocity equals 17.3 meters per second. All right, so squished in there for you. Okay, and then let's look at our last part of this problem. If a force of 800 newtons is applied, all right, let's underline that because that's some info we probably need. Here's our force is applied to stop the car. Oh, that's a weird F. To stop the car at the end of the ride, what is the stopping distance? We're looking for a distance. Okay, so we're over here. So we're looking for this distance right here. Okay, so let's look at what's going on. We know to come to a stop, we need to, so our work equals force times distance. Our work is just our total amount of joules that it's approaching the bottom of that hill with. We know that that is 100,000 joules. There's a force of 800 newtons being applied to it. So once it stops, once it gets to 0 joules, sorry, we'll have this distance. So 100,000 divided by 800, our distance is 125 meters. That's how long it took to stop. Okay, so you're going to look at the other ones. Now remember, these aren't going to look exactly like the other ones. Let's say, for example, down here, in this one, letter F, right? They're saying if the roller coaster came to a stop at 175 meters, here's our distance, what is the force? So we're doing what we just did here, except it's the other variable. So look at what we did up here and just exchange, think about what's going on. If you need help, just email me or send me a message and I will help you.